Continue. Okay. Hello, everybody. Everybody's quiet. Hi, Leroy. Good. Okay, you guys are alive and kicking. That's good. Let me see. All right, Nick, you submitted. You and your group have submitted Lab 3, right? Denise, you and your partner have submitted Lab 3, right? Amanda, you and your partner, have you guys submitted Lab 3? Oh, okay, good, good. Leroy, I assume that you and Ari have submitted Lab 3, right? Okay, good. Don't forget that I also need your rubric that you should have used to grade your Lab 3. Hi, Ari. So if you haven't done so, you can just email me the rubric. You won't be able to upload it on Blackboard anymore because the submission is closed. It's already after 10. So if you haven't attached the rubric to your lab report, please just email it to me. It would be nice if I could get it, let's say Monday, by Monday, because I will start grading as of Monday, Tuesday, and so on. Okay, goody. Another logistics piece that I have to convey to you from the registrar, which I will do now. Let's see. Find that. No, not yet. Where is it? Okay, it's here. So let's find it. There we go. Right, let's make it large. Okay, so here's the thing. This is a continuation of the policy that started in the spring semester. Here is what they say. They say that you can still drop a class with a W, and this has been extended by the CUNY Board of Trustees to the last week of classes. In fact, the deadline is after our last class on Wednesday, December 9th. And there is a step-by-step guide, which I will post on the Blackboard. I just got it, so I didn't have a chance to do so. So this is what will happen. If you choose this option, W means that you withdraw. You're not getting any credits, but your GPA is not affected. That is, as if you never took the course. Of course, you spend time, but if you are concerned, it's not just about this class, it's about any class. If you're concerned that you may be not doing too well, or if you missed a lot, WUs, which is withdrawn unofficially, is not going to be used as far as I know this semester. So if you missed a lot of classes, but you have work done, it may not be a problem for you, but as long as your work is good. But if your work is not what you expected it to be, and you are in danger of failing, that is getting an F. If you get an F, your GPA will be affected, right? Of course, normally you would have to retake it. The good thing is that the F, if you retake and get a C or above, this F is expunged from your record, which is a good thing. If you get a D, your GPA will be affected. And if you retake a class, your D will stay. You will get a new grade, but the D will continue to be factored into your GPA. So sometimes D is worse than an F. Again, the college policy is that we, faculty, cannot give you a grade that you did not deserve. So if you deserve a D, that you earned a D, you're going to get a D, not an F. So there are many little things like this. So remember how you are going to calculate your score, which you should do. Maybe I'll post an activity like this. Okay, so your first component is 10 highest scores on quizzes. Oops, quizzes. Now I misspelled the word quizzes. All right, today's Thursday. Now remember, at this point, the Blackboard shows 12. So your total points column is inflated. It has 2 extra grades that will not be there. So what I will do, probably tomorrow, I will go through your quizzes. If you missed a quiz, you already have dashes in Blackboard. There's nothing that I need to do. If you missed 2, again, there's nothing that I need to do. However, if you took 11 or if you took all of them, you will see 2 grades removed from this, and you will only get the highest of these 12. So for some people, this lowest might be a 7, for others maybe 8. You guys are a good bunch, so hopefully there won't be too many of those lower grades, but quite a few of you missed quite a few quizzes. So again, such as life. So here you can get maximum 100 points. That is 10 quizzes times 10. Your next component is your lab reports, of which you have 3, right? Now, you already have 2 of them. So maximum for each lab is 50 points. Oops. For each lab. So for 2 labs, lab 1 and lab 2, maximum is 100. Right? Because each is worth 50 points. Okay. Now I have to grade lab 3, but I won't do that until I get your rubrics. So I want to see that you guys have worked hard using the rubrics. And your final component, which you can still add to, is 50, up to 50, right? Up to 50 points in participation. These are your activities on the Blackboard. They will be open until 10 p.m. Monday, December 7th. So take advantage of that. Remember that I welcome your own activities. If you read chapter 12 and you found something interesting, and I haven't posted obviously a lot of stuff, then you can create a blog entry for that idea. Questions, if you found something on the internet that has to do with, thinking, reasoning, what else, problem solving, decision making, stuff like that. Post something. Again, it has to be 200 words or above if it's a little essay. And I can congratulate at least a bunch of people. Nick is the first one who achieved 50 points a couple of weeks ago. Congratulations, Nick. You have done quite well. Leroy is very close. I think a bunch of other people are almost there. Remember, I haven't done the activities that are still coming in as of this Monday. So I graded this Monday, which was what, November 30th. So there's another week for you to catch up. So what you can do now, you can calculate, you can do quizzes plus 2 labs plus participation points, right? And maximum is 100, 100, and 250. So at this point, without lab 3, which again, I haven't done yet, maximum is 250. Okay, who can quickly calculate what would be 92% out of 250? So if 250 points is 100%, what is the percentage? What is 92% of out of 250? Well,
So I have a
Amanda.
question.
Yeah, go ahead, Brendan.
So on Blackboard, I see like the grades. It says out of 260 right now. I don't know.
260. Huh.
Yeah, I
Okay.
don't know if it's maybe. I don't know.
I'll have to check all of that, Brendan. I will. So, as a reminder, I had seen questions from people regarding the participation points, and these are Nora, Raphael, Nick, and Brandon. And Nick is fine; he's done. And I will. I think Nora is okay too, and Raphael and Brandon is still on my chopping block. So if you have any issues with the points that you see for your blogs, you think you should have more, you should send me the table with all your contributions. What I need to know is which ones were 1 point, that is everything else except for the cognitive research articles, which were worth 2 points. Plus, if you did the experiment, I know at least 5 people did, that's 4 points. So I may not have, okay, thank you, Leroy. Okay, good. Participation on Tuesdays. Yes, that's a point, absolutely. But it has to be, Karen, it has to be as a blog entry. Yeah, certainly. Okay, next.
Sorry, Professor, can you just say that again? What has to be a blog entry?
The summary of the lecture.
Tuesday's lecture.
Right.
I did not know that.
Okay, Karen.
Too late.
I'm sorry. If you go to the Blackboard and if
Yes.
you go through the weekly schedule, all the lectures are posted. Everything is recorded. If
Yes.
you want to catch me saying that I didn't say that,
No, you definitely said that.
I said it many times. Yes.
You definitely said that. I just totally forgot.
Right. You can still do that. You can still do that. As long as you were present at the lecture.
I was. Yeah, I've been in every lecture except last Tuesday.
Good. So you can still catch up. Of course, you will have to. Yes. Yes.
Rewatch them.
Yeah, you can. Yeah.
Okay, thank you.
Okay, all right. So Leroy, 239 out of 260. No, it should be 250. I don't know why it says 260. So I'll clean it up. But I'm not hurt. Stayed for an hour anyways. Yes, you're good. All right. So now we can say if you have between 239 and 250 for now, you are in the 92 to 100% range, which means this is A. Okay. Okay. What curves, Isaac? What do you mean? Participation points are your curves. No, I don't curve. All right, who can calculate 90%? What is 90% out of 250? It should be 250, not 260. I'll have to check why it says 260. $225. Okay, so Leroy tells us that if you have 225 to 239, you are in the 90 to 92%, and your grade is a, oops, why is it A minus? All right. Who can do 87% out of 250? And so on. So this scale is available to you in the Blackboard. So you can, okay, good. Thank you. So if you have 217, oops, 217 to 225, okay, that's 87 to 90, and that gives you a B plus. And so on. You understand how to calculate it, right? Now remember, if you do well on lab 3, which I keep my fingers crossed for, we've spent a lot of time talking about labs from lab 1 to lab 3. You could be ambitious and add 50 to your count. And that's where, if it is going to be 50, hopefully, you should be close to being perfect on lab 3. You've done 2 exact ones before. Then you can calculate your final grade. So I can't, you still can add participation points. You still have to wait for my lab 3 grades. Ultimately, like I said, I will have, so for now, with the dates, perfect. Yeah, absolutely. You took notes. Good girl, Karen. What was I going to say? That I will be grading this whole week until the end of the week. So that's what, the 13th of December. In the Blackboard, you have a column called total. Total. Now, this column is basically the running count of your points. But again, remember, this column still includes 2 quizzes that will be dropped. So basically, you can take this number, right, and convert it to percentages using 250 at this point. But as you add participation points and lab 3, then it's going to be out of 300. So you will see once I check everything and clean, hopefully if you find something, some discrepancy between what you think you did and what's posted on Blackboard, email me. I promise to double check everything. And then you will see that final count. Okay, there will be another column called leader. Right? That's for your lab reports work as a group. I asked you specifically in your peer evaluation form to either say 50-50. In this case, your grade will be obviously the one that there is also the individual component of which group evaluation does not apply to. So if the leader column says yes, that means that you have been the leader of the group. You put in more time, judging by the history on the Google Doc. So I have at least 3 groups that sent me the invitation. Everybody else should do the same. So I have access to your Google um, group Google Doc where I can see who did what. And these people will be upgraded half a letter point. That's per the syllabus language. And then, so I will post that. So you will see the word yes if you were the leader of the group. And then after that, another couple of days, because I still have other things to do, I will post your grades. And that's that. So I would say December 15th will be done completely. Does anybody have any pressing questions about grading and stuff?
I have a question.
Go ahead, Brandon.
So for the first 2 labs, I had PSY as a partner, and then for the last one, I had Diamond. So should I just like specifically say for each lab how I feel?
No,
When?
only do number 3 because Bishoy dropped the class, so I don't care what what his contribution was. All I need to know is for this last one, was it 50-50 or was one of you the leader? That's what I need to know. Okay, goody. Everybody is okay. You can still, ask me questions. We'll have a little break. Good. Let's stop that. I'll post the message and the link on the Blackboard. So again, if you are concerned with your GPA, W is not necessarily a bad grade. It just means that you lost a semester and you paid, but you didn't get any points. However, your GPA is not going to suffer. So W is a generous grade, and the deadline is beyond the end of the classes, which is totally unheard of for many other colleges or universities. Usually you have to do it ahead of time. So if you think that in some of your classes you didn't do as well as you thought you would, obviously there are many objective reasons for not doing too well this semester. And some of you, at least 2 people who dropped, acknowledged that fact that they could not really work hard enough to get the grade they wanted and they dropped. Again, you will have a chance to do so until December 9th. Okay, peer evaluation. The last, I think it's question 9, the one that has the table in it, asks you to evaluate your partner's contribution to the 3 labs. Again, this is, most of you have the same partner throughout the semester with maybe a couple of exceptions. So I'm asking you to go to your Google Doc, okay, go to File, and in the File menu, the pull-down menu, there is View History. Once you click on that, you'll get a sidebar on the right that will show you 2 things. It will show you all the dates when you worked on the Google Doc, and it will color code each partner. So you may be color coded in green and your partner may be color coded in purple. So it's very easy for me or for anybody to see, who contributed the most, and I would consider this person the leader. And you should then consider yourself a leader if you are the one who contributed the most. Now I'm talking about lab 3, but if you have information about the other 2 labs, you can certainly do that. And I also have some understanding of your dynamics by working with you throughout the semester. But I need you to, so you could go the way and say that it was equal contribution, 50-50. No question asked on my part. You will get the same grade. But if you really contributed and you really pulled through and you helped your partner, I had a couple of groups that had to ask for extensions on the behalf of one partner, so the other one was considerate enough to go with the flow. All of these things, you can put them in the evaluation. Remember, your evaluation forms are confidential. I will not ever share them with your partner or anybody else. So you can always ask me questions about yourself, but you cannot ask me questions about your partner. We have FERPA and HIPAA restrictions these days that are very strict. There's nothing I can do about that. Okay, good. So finally, let's stop that. And I thought because we are, this is not our very last class, but our last class for everybody to be present, and almost everybody is. I think I see 19 people. So I thought we'll talk about chapter 12, but in sort of a more relaxed way. Not necessarily, because you're not taking a test anymore because you already did. So we can talk about things that are more sort of useful, perhaps, maybe less academic, although one thing that I really want to do today is talk about the work of Amos Tversky and Daniel Kahneman, just because their work is so important. In fact, I already told you, actually it was only Leroy and Amr, for whatever reason, Blackboard erased the Zoom links, so not everybody who wanted to join us before Thanksgiving was able to, but Amr, Leroy and I talked about it, that Daniel Kahneman actually received a Nobel Prize for his work in behavioral economics. So it's something that is important. So it may not be totally aligned with the textbook, but at this point, we can just have, I was going to say fun, we can be flexible. So I'm going to talk a little bit about reasoning, decision making from the two perspectives. So I will sort of like two parts to today's conversation. I hope it is conversation. We'll talk about judgments, and these are the heuristics that Tversky and Kahneman tested in the very early work of 1970s. But the good thing or the bad thing, that these heuristics are with us every single day, regardless of whether this is 1971 or 2020. So that's one of the reasons why we study classical psychology, classical cognitive psychology, because so many of these earlier principles and theories still explain our behavior. And then hopefully maybe I'll have some time to perhaps answer this philosophical question: are we rational as humans? Because basically that's the only class where you can talk about logic and thinking and high level functions, and we only get to them at the end of the class, unfortunately. All right, so I'll start with this quotation from Alexander Pope, who said 1711, to err is human. That is, we are designed to make errors in our judgments, in problem solving, in decision making, in reasoning, all the functions that constitute this last module of our course. Of course, as always, yes, Leroy, you were right. If you bookmark, then you don't lose. So for the future, as you know, guys, you're going to be online in the spring. We will be online in the spring. When you get Zoom links, of course, Ultra Collaborate is different, but if you get Zoom links for your other classes, bookmark them. Leroy is absolutely right. Okay, so let's start with judgments. We started talking about judgments in the relationship to algorithms. And again, this was last Tuesday, November 24th. And Leroy and I had fun by looking at the Tower of Hanoi problem. Actually, let's make it 3. That's just to remind you, here is, okay, let's put it this way so you can see ABCs. It's a well-defined problem, okay, where the initial state is 3 disks on peg A, and the goal, the solution, the goal to solve the problem is to have all 3 disks, right, be on peg C. All right. It's a handy toy from one of my children. There are two operators, that is the restrictions on how you can solve this problem. One operator is you can only move one disk at a time. So this is a legitimate move, and this one is not. The second operator, the second restriction, is that you can never have a larger disk landing on the smaller one. So this is legit and this is not. Okay. Obviously, the goal is to go through this puzzle in as few steps as possible. And Leroy first stumbled a little bit, but then he fixed it quickly. Okay, is anybody besides Leroy and Amr, who were with me then, is willing to walk us through this problem while we count your steps, which will be intermediate states? Karen, you have your mic that works. Would you like to try? Nick, would you like to try? Oh, Jeffrey, perfect. I see. Okay. Jeffrey says he can try by typing. That's going to be a little too slow. Karen, yeah, we can manage if you speak quietly, right? So please unmute yourself. Uh-huh.
Do you hear me?
Yeah, perfect. So tell me, what should I do first?
Take the red ring and move it to B.
You guys, everybody else, count the steps.
Okay, take the green ring and move it to C. And then take the A ring. Does it matter where I move it?
Well, remember, this is the largest one. It can
Yeah.
never land on top of the smallest ones.
Okay, so take the red ring and move it to C.
Okay.
And then take the A ring and move it to B.
Excellent.
Can the green one land on top of the red one?
No, because green is larger than red, right?
Yeah. Okay, so then take the red ring and move it to A.
Uh-huh.
I think I
Perfect.
made it more complicated. Okay, then take the C ring and move it to B.
Uh-huh.
Okay, and then take the red ring and put it on green.
All right. But remember, Karen, the goal is C, not B.
Yeah. Oh man.
Okay, not a problem. All right. Jeffrey, would you like to do it by typing? Just, say, okay. No, lol. Okay, Jeffrey, by typing, by saying, red to whatever. Go ahead, Jeffrey, and you guys can watch it in the chat, but I can also say that. Go ahead. Red to B. Green to C. B to C. Blue to C. I can't do that. Red to C. So give me the color and the peg. So that will be easier for me. Blue to B. Yep. Okay. red to A. Oh, you're going to make the same error as Karen did. No, that's not going to work. There's only one other move, right? Jeffrey, shoot. Okay, which is the other one? If red cannot go to E, where should red go? B, yes. Okay, Jeffrey, now you can quickly do it. What do I do with the green? Green to A. Red to A. Perfect. Blue to C. Yeah. Red to B. Green to C. Yay. Fantastic. Beautiful. So here's an algorithm to solving the Tower of Hanoi. You know, we don't need to go back to what we did a week ago, but this algorithm is, it's simple with one exception. That exception is here. At this intermediate state, the problem is, and that's why Karen hesitated, and Jeffrey was also trying to do it, that this disk now has to go back to its initial peg. And we hate that. We hate that because we don't like backtrack in our problem solving, but we have to. Otherwise, we cannot solve the problem. And this is an algorithm because you can program a computer to do it. And obviously, you guys did it. The beautiful thing, let me just repeat that for those of you who are not with us. Now, of course, you can imagine if it is an algorithm, so let me do that. Not that I'm asking you to do it because it takes a little bit longer. You can do it with 4 disks, okay? Same idea. You need to move all the disks from A to C, following these 2 restrictions. And it's the same algorithm, it's just 17 moves instead of 7 or something like that. The legend says that in Hanoi, which is in Vietnam, there is a temple. It's a sacred temple. There are monks there. And in one corner of the temple, there are 64 golden discs. Okay, so this is 4. Now imagine 64. The monks have to do the same. They have to move these 64 discs from this corner to another sacred corner in the temple, and there is an intermediate place where they can put discs, following exactly the same restrictions. They can only move 1 disc at a time, and they can never put a larger disc on top of the smaller one. And the legend says that when the monks finish this problem, that is, they will move all 64 discs from one corner to the other, the world will come to an end. So now, with the exception for Leroy and Amr, how long do you think it will take monks to do so if they imagine, that's a thought experiment, if the monks could use just 1 second to move 1 disk? Of course, it's not realistic, but how long will it take? Guess. You can guess it in years, for example. Yeah? Well, the good thing is it's going to take 5 billion years if each monk takes 1 second to move 1 disk. So don't worry. It's not going to be solved anytime soon. Anyway, so this is an algorithm. Do this, do this, do this, do this. As humans, this is the idea. If we are rational and we use algorithms for well-defined problems, it may take us a while, right? Like 64 disk problem will take 5 billion years to solve, but it's solvable. So, and the good thing is that these algorithms guarantee that you will solve the problem. So You will never make a mistake because you're following the algorithm, but it might take you a long time. Presumably, and this is the idea of the rational behavior, people do that. When Kahneman and Tversky started thinking about it, they said, no, it doesn't look like people actually use algorithms like this. What they use, more likely, something that they called heuristics. And here's the word heuristics in the title of the slide. And heuristics is a bunch of heuristics is something that we call a rule of thumb. So something that you can do quick and dirty. It will save you lots of time, right? It will save you lots of cognitive efforts, but you can make mistakes, right? So when the conditions are uncertain, and most of our problems in this life are uncertain, we may not be willing to use an algorithm. We might just go with heuristic, okay? So in this case, we will bypass the logical rules, right? We will perhaps make errors, but we will save time. Okay. So heuristics are used when we are making decisions under the circumstances, the conditions that are being uncertain. So you can think about application of all of this now. I mean, we have Christmas coming, we have perhaps winter break if you're not taking winter intercession classes. I mean, should you travel, right? That's could be, should you travel to visit your extended family? Should you just travel to Florida, whatever? Now, these are conditions of uncertainty. You have to bring in all these potential uh, facts that you should know about COVID and Florida and whatever to decide whether travel is a good thing to do. Now, instead of, so you could use an algorithm, right? You could see what is it, what the numbers look like in Florida in a particular place where you're going, and so on and so forth. Should you fly? Should you drive? All these facts could give you a pretty good decision, but it's going to take you a while and it will be frustrating because it takes a lot of efforts to do so. All right. So what Kahneman and Tversky in the bunch of the experiments that I will describe to you next came up with, they came up with classification of these judgment heuristics, and that's what we will call them. We'll call them judgment heuristics. And there's the four, it's actually more than, of course, there's like 20 of them, but these four, representativeness, availability, simulation, anchoring, and adjustment, are the most frequently used ones. And these are the ones that Kahneman and Tversky checked in their original experiments from 1970s. So we'll talk about each of them for a minute. So let's start with the representativeness. Yeah. Actually, when we did concepts and categorization, we talked about it a little bit. So let's look at representativeness from a different point of view today. So I'm going to ask you guys to have your notebook nearby, or Leroy, of course, you can type. I'm going to ask you to perhaps do a little bit of problem solving, decision making, so that you can understand how these heuristics work and try to catch yourselves using heuristics in your everyday life. All right, so let's start with the representativeness, like I said. Here's the first, well, let's think about it as something when we have to judge things as being similar, or maybe a probability of a coming event, right? So what is my probability of getting infected if I travel to Florida? So here's the first problem that I'm asking you to do in your notebook. Let's say we have a family that has 6 children. Which of the 3 outcomes listed on the slide, 1, 2, or 3, is the most likely sequence of boys and girls? Is it A? I mean, is it 1? Is it 2? Or is it 3? So let's go to participant manager. So let's start with 1. Who thinks that 1 is the most likely sequence? Then click on yes button. And if you don't think it is the most likely, then click on no button. Good. Perfect. So everybody thinks it's not the most likely one out of those who voted. Okay, great. Let me clear that. Let's do 2. Do you think that 2, boy, 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 girl, 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 is the most likely one? Good. Again, everybody agrees that this is not the most likely sequence. All right, I'm going to clear that. Let's do number 3. Boy, girl, boy, boy, girl, boy, girl. Excellent. Okay, no, of course it's a tricky question. It's not really a tricky question. The reason why you guys and the participants in Kahneman and Tversky's experiments chose 3, because our intuitive understanding of randomness, and we assume that gender, sex, biologically is random, right? So your chances of having a boy or a girl are not specified by something else. So the idea is, if something looks more random to us, that's what we, and then we say, okay, well, there is a balance between men and women in the world. So a sequence that looks more balanced is the one to choose from. But here is the thing, right? If you ever studied logic, our probability of having a boy or a girl is always 50%, right? 0.5. And our probability of having a second child of one gender or the other is also 50%. So the second child's sex is completely independent of the first child's sex. So the answer to this problem is that all these 3 sequences, A, 1, 2, and 3, are equally possible. Now, of course, if you take 2 million people, then things become slightly different. But each subsequent birth is independent in terms of sex from the previous one. And perhaps I actually have a friend who had 4 boys. And then she and her husband, they said, okay, let's do it last time. Well, now surely we're going to get a girl. And of course, guess they got boy number 5. Because each birth is independent. So if we start multiplying, this is how we calculate probabilities. When you guys go to 266, you'll be doing that. You take 0.5, multiply 0.5, do it 6 times, you're going to get about 15%. So there's a 15% chance of each of these 3, and it's exactly equal to, have either of the sequences of boys and girls and so on. But we as humans, we use the heuristic. We think, okay, genders should be distributed approximately equally, and they should look random. So 3 is the answer, right? So if you guys start getting children after having 3 girls, you decide to go for a boy, stay put. It may not happen. All right, a more sort of practical way of thinking about, and this is what Kahneman and Tversky found, that in terms of judging the probability, people went for number 3. So that is 1 to whatever, 80%. And only very few people chose the other 2. So our rationality, we could calculate the probabilities, but we don't. We use a heuristic. So I'm going to skip the details of mathematics, not 15%, of course, I was wrong. 1.5. Let's look at something, perhaps some of you know somebody who gambles. All right, Russian roulette, yes, invented by Russians. Okay, so we have a roulette wheel. Half of the numbers are red and half of the numbers are black. Let's look at 3 possible runs, 1, 2, and 3. And I'm asking you to guess what would be a continuation of run number 1. Is it going to be a red or a black? What would be a continuation of run number 3, red or black? And what would be a continuation of run number, I'm sorry, this was 2. Continuation of run number 3. Is it red or black? Okay, so who can type a guess for number 1 in the chat? Okay, Jeffrey says red. Okay. Leroy says black, red, red. Okay. So now I'm asking you to stop thinking as yourselves, but start thinking from the point of view of a logical human being, the one who supposedly follows the rules of logic. Now, you saw the birth problem. This is exactly the same problem. What is the probability of getting a red or a black? Exactly, Parker. It's 50%. Again, which means that in any of these outcomes, what about green? Yeah, well, let's assume that we're not discussing that. The probability of getting a red or black is exactly the same in all 3 sequences. But which one looks the most unrealistic? Of course, it's number 3. It's all black, 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 right? There is a story, I think I read about it once. The woman, yes, a woman played, I think it was, I don't know what she was playing. Anyway, so she got exactly sequence number 3. Black, 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 black. And she kept saying, okay, now red should show up. She kept losing until she stopped. She left the table and her cousin, who was with her but playing something else, came and she bet on black and she got the jackpot. So this first woman went to the casino administration and she said, no, she has to split the jackpot with me because of all the blacks that came before her, red was supposed to come now, and it did. So she got the jackpot, but it was because of my hitting 20 blacks in a row, whatever that was. And of course, the casino administration gave her a little lecture on the gambler's fallacy, saying that each of these runs is completely independent of the previous one. Therefore, they denied her demand for her cousin to split the jackpot with her. So be careful when you're looking and thinking, oh, probably the next one, the color should change, because you will be in the gambler's fallacy situation. A very, very common problem. And we have plenty of stories about people who would go for different sex and winding up with, in one case, they had 3 boys, wanted a girl, and got twin boys on the 4th try. Yay. Okay. So why is it representativeness? Because in our mind, we represent probability this way, right? We would like our sample. Remember, a little sample is 8 runs or 4 runs. Represent the population. What is the population of all boys and girls? And what is the population of all red and black colors? But it's a sample. It's not a population. It doesn't have to resemble it. Well, at some point it will if the numbers are large enough. So we often use representativeness heuristic because of similarity. And the reasons why we're having problems with that is, actually, yeah, remember, I think that story with the woman and her cousin was in New York Times. That's right. So what are the problems? We don't take into account the base rates. A base rate of 50%, right? And we fail to take into account prior probabilities. In this case, there is no prior, there is a 50-50, again, a prior probability. So if we were to apply the rules of logic instead of heuristics, we would have figured out that it doesn't make any sense to go for yet another child because it can be another boy, a 50% chance. Or we should not expect a jackpot thinking it's going to be red, because again, we failed to calculate the fact that these two probabilities are independent. Now, of course, I'm not suggesting that you guys should always do algorithmic thinking, but sometimes it helps. Okay, so it's not a bad strategy. In fact, using this similarity, does it look like what it should look like in population, often works quite well. Especially when you categorize. Remember, we had the little exercise of you guys categorizing all the cups and mugs and whatever. It helps, it works, but there will be occasions when you will make mistakes, like having boy number 5 after 4 boys. You have to be prepared for that. Here is an interesting way. Like I said, today we can talk about things that are maybe a bit less research oriented, more applied oriented. This is how representativeness heuristic plays out in real life. Maybe you can think of examples from your life. So here's my first example, is sex education and birth control. So we spend a lot of time in schools telling our teenagers about birth control and actually making it available to them. And a lot of public parents sometimes oppose sex education in the schools. And the assumption is that sex education, birth control will cause premature sex activity in these teenagers, and therefore would result in pregnancies and abortions. But now that we know, doing a lot of research in schools, that any increase in teenage pregnancies actually occurring since these policies were introduced, which is, another 50 years, 40 years, increased only because the number of teenagers in our population increased, not because, if anything, sex education and condoms and pills and whatever else they may give to these teenagers keep the rates of pregnancies and abortions lower if you take the proportion of teenagers in our society when it used to be before the policy. But again, the representativeness is thinking, okay, if you tell them about sex, they're going to go and do it. Think about your sex education class, if anybody remembers that. Did you act upon that? Here's another example. Again, many people, let's see what you guys think. So let's go back to our, let me clear that. Let's go back to participant manager. So here's my question to you. Do you think violence in movies or video games causes violence in real life? If you think yes, then click yes. And if you don't think so, click no. Good. Okay. A lot of you are thinking about it now. But many people in sort of in population think that if we show violence in movies, television, and video games, it will cause children, adults to behave violently in society. And this is kind of intuitively appealing, but it has been extremely difficult to prove this point. And you can Google this, and if you want, you can use that as one of your activities. Yeah. See, Justin, you say some. Again, this is your representativeness. Why don't you do some Google search? Maybe not now, but when you have time during, the late part of December, and see if it's true. Okay, see if it's true. Do we have any science? And we have now plenty of studies that people have looked at, studying with Bandura's classical study of Bobo doll. Here's the third example. Many people think that promoting music and art education in the schools because they believe that these programs will improve, enhance student achievement in other domains like STEM, science, technology, engineering, and math. Um, well, of course, maybe having a music and art education will make people look smarter. There's actually no evidence of any causal relationship between music and art education and academic achievement in math and science. So it's actually maybe the other way around. So if you are in a school with a large population of high achieving children, there's a pressure to give these school children a possibility of having arts and music. Something that is kind of relatively new thinking in this uh, applied approach to representativeness. Let's see if I have it. No, not yet. So I'll go back. It has to do with e-cigarettes, with, you know, replacing real cigarettes with vaping. Does anybody use e-cigarettes? How about we do another little poll? So if you vape, click yes, and if you don't, click no. Oh, okay, interesting. Well, you guys are good. Mm-hmm. All right. Perfect. There's only one person who vapes. All right. Um, so public policy uh, people mm, object to e-cigarettes precisely based on the representativeness heuristic. That is, vaping looks just like smoking, right? And smoking is bad for you, so don't, right? Um, Interestingly, one of I'm looking at the citation. A spokesman from campaign for tobacco-free kids said the following: if it walks like a duck and it talks like a duck and it sounds like a duck and looks like a duck, it is a duck. So saying the, e-cigarettes just like regular smoking. But we know that the most damage comes from inhaling the smoke of nicotine. But there's um, some interesting research that shows that vaping is not as uh, I wouldn't say the word bad. Any smoking is bad, but less damaging than people think. So again, if you're interested in seeing how this representativeness, it's because vaping looks like smoking, affects legislation that is applied to e-cigarettes, you should Google that. And again, you can use that as your uh, activity if you want to. All right, let's move on to the next one. Availability. Here we use availability when we judge frequency and when we judge probability as well. Now, availability means that something that comes to mind easily when you think about it. So let's something that's based on your previous experience. So let's do another little problem. Clear that. Okay, let's estimate. Again, this is all classical work of Kahneman and Tversky. Let's think about words of English that either start with the letter K or have letter K as their third letter. So I didn't number it correctly. If you think that there are more words that start with the letter K, then click yes now. And if you don't think so, then click no. Mm-hmm. Good. Good. A bunch of you are voting. Mm-hmm. Good. I have already warned you enough, right? So there are two answers. One is what you now think after we've spent an hour talking about heuristics that can lead to erroneous judgments versus what naive people do. What naive people do, and these are the results of Kahneman and Tversky's experiments, is choosing beginning with letter K as more frequent choice because it's much easier to come up with words that start with a K, right? No, night. I mean, they're not, K is not pronounced, but it's there. Versus, what would you come up with a K in the third position? Can somebody give me an example in the chat when K is in the third position? Like, very good. Wake, woke, naked, make. Thank you, Parker. Perfect. Right. So now, if you look at the Webster, this is Merriam-Webster's, K in the initial position, I'm looking at my numbers because I don't remember, is 152. K in the third position is 283. All right. And if you repeat this exercise for the other four letters here, L, N, R, and V, you're going to get the same results. So in general, the total number, I think I have a slide for that, right? Right. So if you look at the actual counts, just under 2,000 are the words where these five letters are in the first position. Three, well, not three, right, but almost 3,500 words where these letters are in position 3, but that's not how people judge that. They judge first letter as more frequent than the third one because of availability. It's much easier. We did that, mental lexicon, your lab 3 perhaps. We do retrieve words from our mental lexicon by the onset, by the beginning of the word. So it's much easier to think of K in the beginning than the K in the third position. Okay, let's do another little problem. Okay, so type in your answer in the chat. So let's say we have 10 people. How many different committees of 2 people can we create? That's question number 1. And the question number 2 is how many different committees of 8 people can we create out of the same group of 10? Nope, no volunteers. So Denise says 5 committees of 2 and 1 committee of 8. Well, Denise, we're talking about different committees. So imagine that we take person number 1, a lot more, and then pair it with person number 2. That's committee number 1. We take person number 1 and pair it with person number 3. That's committee number 2, person number 4, and so on. Brandon says a lot more. Now I want you to try to compare this number. Let's say we have these 10 people, right? And we take 2 out of these 10, whichever 2 doesn't matter. What's left? Well, what's left is 8. So if you can create 1 committee of 2, you can create 1 committee of 8, right? So the answer to whatever this number is, which is, I think, 45 or something like that, it's the same, because each time you take 2 people out of 10, you have 8 people left. So there is always will be the same number of committees if you have 10 people. But again, if you give this problem to participants, which is what Tversky and Kahneman did in 1973, for 2 people, people estimated significantly more committees than for committees of 8. But the solution is right. It's 10 minus 2 is 8. So there's always the same, whatever this number is. It's going to be the same. It cannot be different. But again, availability, why? Because when you trying to create and think about committees of 2, it's kind of easy. Like I said, 1 to 2, 1 to 3, 1 to 4, 1 to 10. But when you start thinking of 8, so you have person number 1, person number 2, 3, until you get 8, and then you become quickly overwhelmed, and you say, you give up, and you say, okay, that's going to be not that many. Here's the actual number. I was right. It's 10 in the power of 2 in the power of 10, or so on. You can get 45 different committees for each of these 2 groups. Again, if you use an algorithm, if you use binomial coefficient, that's all it takes, you will get your answer immediately. But we don't do that. Who does that? Who's that stupid? Okay. So what happens with the availability, it's just because we can think of something from our previous life that would be available to us. And therefore, if we have lots of instances we can think of, then we decide to choose that. Okay? But we can, in the process, we ignore all other things. For example, priming that we talked about when we talked about long-term memory in chapter 6 of this course. Priming can do something to you. It can change what is available. So again, the classical example from everyday life is a question that can be posed to people before maybe COVID. What are your chances? When are your chances higher to die in a car accident on the way to the airport or on your flight? And a lot of people, naive people, right, say that of course your chances of dying on a flight are higher. But we know that this is exactly not. I mean, your chances of dying in a so in the airplane is like 1 in a million, but your chances of dying on the way to the airport are very, very high compared to 1 in a million. But because our mass media represents a lot of cases that are so vivid, as yet another plane that just crashed, we start thinking of that as having a high probability event. Another well-known case is when people are asked to judge the probability of dying of fire versus dying of cancer or something like that. Again, the availability heuristics does it to us. We think about cases that we've heard and we choose a totally different answer if we were to actually calculate that using a heuristic. Okay, what is it? It's 11:22, so let's take a 6-minute break until 11:28. Okay, and then we'll finish the other 2 heuristics and maybe talk a little bit about rationality. If anybody has a question for me, ask me now.
I have two questions.
Go ahead, Brandon.
It's one with the assignment, the grading. Are you
Hmm.
doing full credit or the partial credit? Because on my thing it says 39.5. I didn't know if
Hmm.
you were doing, you said you were going to go back.
Yeah, yeah, I'll be
And
happy
if
to.
not, I'll just know to do an extra assignment or two.
You should do it anyway,
Yeah.
Brandon. Why not, right? You're going to learn a thing or two, but I'll try. That's why I'm asking anybody who is happy with who is okay with the points right now, fine. I don't need you to do anything. I'll finish the calculation in the remaining few days. If you want me to give you the points that I in the beginning subtracted because you were not doing it right, then I need that table from you. So send me the table where you say these are my 1 point blog entries and these are my 2 point entries.
Okay.
So you sent me this, right, Brandon?
Uh, no.
Oh
You
no, you
sent
could
me
not.
what you had on your
Right,
end, and then
right.
once
You
I
could not.
finish, I'll send it back to you.
Good. You could not access some of your blogs. Okay,
Yeah.
that's and I could not download all of them. I can download each of them separately. So
That's fine. I could access the articles, and I'll do the 2 point
oh, good.
questions.
Okay, good. So again, let me repeat. I've heard from 4 people, including Nick, who's fine. He's done. Brandon, I just talked to. Noor and Raphael. Anybody else who wants to get maybe another point that was not given to you because you made a bunch of errors in the beginning, send me a table with all your single point blogs, all your 2 point blogs, and I will make sure that I will adjust your um,
Do you want us to put them by names, or do you want us to just put like maybe from September 6th to
yeah,
a
yeah,
specific date?
yes, Denise, yes, the week number or the date is what I need. I don't need the actual 4.3. You can just
Uh,
say week 7 1 point or whatever, and
oh,
I'll
okay.
I'll
Okay.
I'll adjust that. So of
All
course
right.
in the beginning I was I'm gonna make sure that you guys are doing. You can still do those that are um, available. Yes, Amanda, but I think most of them, except for the past month, actually are closed. So try to, if you need more points, try to do them this week this week, past week, November, basically. I think all the November activities are open, but I need to check. Right. So I don't want like I thought maybe I needed to be, uh, I don't need to be so fastidious. If you have done some work, even though you did not do assignment of variables correctly before, that's okay. You've learned a thing or two in this class about variables.
And another question with the lab
Mhm.
3, I
Uh-huh.
was I know I 100% was under the correct way to send it in, but I got
Mhm.
a email from Veronica Di Meglio that I sent it to her, and I was really confused because I know I was under lab
Yeah,
3
yeah. She's
submitted.
she
Yeah, I
sent
don't
me
know.
the same email too, saying that here is somebody who submitted his lab to me, but I assume it's for you. No, it's fine, Brendan. I see it on Blackboard, so you're okay.
I was just really confused. I wake up, I see I didn't send it to you, and I'm like, I know I sent it to you. I just want to make sure it's there. You also
Yeah,
got
it's there.
the graded pictures, right? The rubric.
When did you send that? Did you
I
send it
sent it
today?
with the lab. I sent the lab link, and then I sent the 2 pictures of just the rubric, front and
Oh,
back, with
okay.
what we
Yeah,
graded. You got
I think I do have. I can check my email right now and tell you. See if I have a message from Jeff, Nick, Melissa, uh, Isaac. No, Brandon, I don't. Do you still have it? Why don't you resend it to me? Because I don't see it. The email that you sent me, just
send it
send
to
it to
your
me
email.
again.
Okay.
Yeah, I'll check, make sure that I have it. Okay. let's get back to the other two that I want to talk to you about in terms of heuristics. So number 3 is simulation heuristics. Again, a lot of probability judgments come under the rubric of simulation, and also causality. So let's have a look at one of the problems where people would use such a heuristic. So imagine a scenario that there are two different travelers, and these people are flying, let's say from JFK. They're flying on two different flights that leave at exactly the same time. I mean, at JFK, it happens all the time. So they both are staying in the hotel. They run out of the hotel to grab a cab, and they decided to share the cab. Obviously, they are going to JFK. They are not related to each other. They just happen to be uh, uh, on two different flights at the same time. And the cabbie tells them, Uber driver, whoever is taking them, saying that we are going to be caught in the traffic jam. So I'm sorry, guys, you're going to miss your planes. Right? So when they get to the airport, the first guy, A, finds out that his plane left on time, which is half hour ago, because they are 30 minutes late. The other guy, guy B, finds out that his plane was delayed by 25 minutes and he only left 5 minutes ago. So the question is, who is more upset? Is it the A guy or the B guy? Now, of course, you guys now are prepared to answer this question. You would say, okay, we know. Obviously, people in the Kahneman. So now I'm asking you to think of what the participants did. Yes, Leroy says B. So the B guy, exactly. And the reason why, it's because of a simulation heuristics. And so a heuristic, I guess I could say that. Oops. And these are the decisions. Yes, Amanda. Oh, it happened to me once too in Leipzig in Germany. It was bad. Anyway, so as you can see, 95% of the people estimated that the B guy is going to be more upset than the A guy, right? But if you start thinking, so why? Because it's easier, right, to imagine ways how you could have shaved 5 minutes. What if you hadn't brushed your teeth? If you hadn't, you know, watched the last of that show? It's much more difficult to see how you would have saved 30 minutes when you're late, right? If you had only gotten out of bed 5 minutes before when the alarm clock rang instead of snoozing, something like that, right? And if you haven't stuffed the donut in the hotel lobby before you grab the cab. So in your mind, right, you are simulating, kind of simulating. You're thinking about what you could have done differently to, gain these 5 minutes. So it's the plausibility of the scenarios that can be constructed. So the B scenario is easy to construct, 5 minutes. The A scenario, much more difficult. Therefore, people go for the B, saying, okay, this guy is going to be more upset. And in fact, this is what we find in something when people look at, if I haven't used my phone 5 minutes before. Yes. Okay. So it's the ease with which we can construct plausible scenarios when we could have changed the situation. Okay. But it's not about the memory, right? It's not about availability. The way availability works based on your previous experience. This is based on imagery. If you remember our chapter 8, which was visual imagery, easy to imagine. Okay? But if you start thinking about it from the point of view of logic, and this is what we're trying to do, then from the point of view of logic, it doesn't matter, right? The planes, both of them, left. So why be upset? Well, why would one be more upset than the other? Both should be equally upset because It's nothing you can do, right? The problem is, of course, here's the problem at the bottom of the slide is, um, how do you know that your imagined scenario would have occurred, would have taken place? This is what you think. It's your imagination, but it's not what could have happened or would have happened, right? So if you think, like I said, in the research on emotions, often considered a potential subsidiary of cognitive psychology in the area that we call social cognition. We didn't have time for that. But in social cognition, we study emotions and we study the way cognition and emotions interact. Obviously, they do a lot. Think about motivation, for example, right? So think about these four emotions that are known in the research as counterfactual emotions. So frustration is one of them, right? Regret, grief, and indignation, right? So in the case of undoing problem, it's frustration because, hey, if only I'd got out 5 minutes earlier, right? So it's interesting to see how, and this is what I hope we'll talk a little bit on Tuesday because it's our last class, is bringing together multiple ideas from which we began. So, now you're done with this class basically, but maybe you have other classes. I would encourage you to listen again to my very first lecture, the one that I couldn't actually deliver to you live because I was on the plane, about the trilogy of mind. And the trilogy of mind is what psychology is all about. Now, in this class, we focused on cognition, one of these three-prong approach to mental life, which has to do with knowledge. But there's also emotions and desires. And these two are studied more in other areas of psychology. But there are multiple connections that are very interesting. So a lot of new research in cognitive psychology is actually at these sort of boundaries of knowledge, desires, and emotions, or knowledge, desires, and motivation, where you can learn how to do very exciting research with neuroimaging and study social cognition. How do we acquire knowledge as a species, in the group, in interaction with other people, in class, for example? Okay, so that is something that we um, do a lot in modern cognitive psychology. My approach to this class was more classical in trying to show you the principles and theories and experiments that have been formative for cognitive psychology as it evolved in the 1970s and continues to evolve throughout today. But a lot of methods today are neuroimaging methods, not the behavioral ones that we used in our three labs. Finally, the fourth one that I wanted to talk to you about today are anchoring and adjustment heuristics. So that's the fourth one. Again, this is usually used when we have to do some estimates. Okay, so let's do another little exercise. I'm not asking you to use an algorithm, I'm asking you to do an estimate. So type in your estimate for sequence number 1 in the chat, or sequence number 2 in the chat. It's an estimate, so you're not using your calculator. Okay, Jeffrey says 500 for the first one, Jeffrey? What about the second one? Both. Okay. Anybody else? Okay, Karen, 500 both. I'm doing the second now. Okay, good. All right, you don't do it. Try to estimate, and that's the whole point. Again, it's a well-defined problem. If you use an algorithm of multiplying, you will get the right answer. But the idea is to do it quickly. Okay, Brandon says about 3,000. Which one, Brandon? The first one or the second one? Both. Good. Yes, Amanda, you're absolutely right. Both of these, it's the order that's different. But when it comes to multiplication, the order doesn't matter. So in that point, you guys are both correct that they should yield the same result. But when we present this problem to our participants, okay, who can estimate, who can guess which one people estimated to give us higher product, the first one or the second one? That is, which of, for people who did not consider them to be the same, the first one, yes. And why would that be the case? Well, because when you start multiplying 8 by 7, that's 56 times 6, and you're like, oh God. And then times 5, and versus 1 by 2 is 2, 2 by 3 is 6, 6 by 4 is 24, and so on. It sounds like you can do that, right? For a while. So when this problem was given to Kahneman and Tversky's participants, the actual result is 4,320. Sorry, guys, not 3,000, not 500. But for the descending order, right, for 8 times 7 times 6 and so on, people estimated it much higher than for the sequence of 1 times 2 times 3. And the reason is because you anchor yourself, right, at 1 to 2 to 3, much easier than anchor yourself at 8 to 7 to 6. Okay, another one. These are all of that is from 1970s. As you can see, except because you're way off, that's right. Because we are now in class where I'm discussing all of this with you, you would have been 2020, think about your birth problem, the first one in class, you would have been exactly the same as people 50 years ago. Nothing has changed. We haven't become any more rational than our parents or grandparents. So let's do this one, the United Nations problem. Okay. The question is, again, put yourself in the position of participants in Kahneman's and Tversky's studies, not yourselves, because now I have ruined you, hopefully forever. Let's estimate the percentage of countries in the United Nations that are from the continent of Africa. And I'm going to give you, so people were divided into groups. The first group was given the estimate like this. They were given this problem, and they were also given the fact that some people before them said 10%. So 10% of the countries in the United Nations are from Africa. Now, the question is, what do you say? While the other group got another estimate. Some people before you said 65%. What do you say? So you can see now how the scenario will evolve. Obviously, when people are given a lower estimate from somebody else, their own estimate is going to be lower, right? When they're given a high estimate of 65, their estimate will be higher. And that's what they found, right? So for people who were given the estimate of 10%, they only estimated about 25% of the countries were from Africa. And people who were given 65% estimate gave 20% estimate more, right? So they were sort of anchored, right, by the previous estimates of some other people of whom they didn't know. So people do anchor their judgments on whatever information is available to them. So in this case, it was presented in the problem. And then they adjust their estimates based on this in the same direction. So if you're giving a low estimate, you're going to give by somebody else. You're going to give an estimate that's lower to you, right? Perhaps some of you, not maybe anymore, but yeah, no, we still get that by email. We get these solicitations from various organizations that would like us to donate money to the cause. Have you ever noticed how these options are listed in either email or in the old days in the card or in the publication? So they stay. So let's say Museum of Natural History. Would you like to be a friend of Museum of Natural History? Please donate $100, $50, $20, $5. So it's always in a descending order. All right, because if they suggest 100 and you say, okay, well, it's a good museum, maybe I should help them if I can. $5 doesn't sound that much, right? Compared to 100. Now imagine that you received exactly the same solicitation, but the choices are now reversed. So you can give us $5, $10, $20, $50, $100, and you say, whoa, $5, that's steep, right? Maybe I'll give them $1. So that's anchoring. And a lot of sort of marketing research people know exactly how it works. And they sort of play it on us in everyday life. So you guys are now armed with understanding of heuristics that and the good thing or the bad thing is that we actually, it doesn't matter whether you're an expert, or maybe if you teach that in my situation might be a bit better. Even experts are not immune to these problems. Even experts fall for these shortcuts. Now, before we move to my next, and we have another 20 minutes, we may be able to talk about a little bit about are we rational? Well, let's finish this. And then what I was going to say is I want to show you an interesting site called Good Judgment Project. But let's finish that, right? So we often start our estimates with the initial value. If this initial value is low, then our estimates is going to be lower, and that serves as an anchor. If initial estimate is higher, then our estimate will be higher. Again, the initial estimate serves as an anchor. Okay. The problems here, we are not doing full computations. We're doing partial computations. That leads us to make errors. And we're not doing enough adjustments based on what is given to us. This is also well known in psychology as the power of first impression. And again, that's something that you could do for your participation point, if you would like to do that, is to see how long it takes for people to form their first impression of somebody else. An easy example is when you sign up for a class and you're going to take the first class, and how long does it take you to figure out whether you're going to like this class or not? I mean, is it 5 minutes? Is it 2 minutes? And many classroom-based research showed that sometimes it takes 30 seconds for you to decide whether you will do well in the class, whether you like the way the class is going to be conducted. So the power of first impressions is incredibly, well, I should say powerful. First impressions are incredibly powerful, but they can also, thinking of anchoring adjustment, they could also mislead you to thinking differently from the way it will end up in the end. Okay. All right. So before we move on to this, I'm going to show you this very interesting site. Just make sure that it's open. Okay, good. So let me share the screen with you. Now, where are you? Okay, let's go down. There we go. All right, so it's a little small, but it doesn't matter. So the site is called goodjudgment.com. And here, what they have is a group of people who they call super forecasters. These are the people who can forecast future events based on current information. So now remember, you can either use algorithms or you can use heuristics to help do something like that. Now, of course, the site has been going on for a while. This year, we all are about Corona, about the COVID. So here is, for example, what these people uh, were asked whether the FDA approved vaccine will be available and when it will be available. So one could look up at so the predictions started coming in March. That is almost 9 months ago. And now you can see it's a little small, but maybe I can make it bigger. Let's see. View today's forecast. Now we can do that. Let's see if it loads quickly enough for us. So when asked so today's forecast, which is December 3rd, right? Out of these experts, these are the numbers. When do people predict the vaccine to be available? And as you can see, 84% of super forecasters say it's going to be available between November 4th and January 2021. That sounds good, right? 15% say no, it's going to be a little bit later, from between January and May. And basically nobody says that it's going to be available later than that. So here is the figure showing how they were predicting this. This is from September 25th. You can see the dynamics. So September 25th, they said between January and May. And then this number started going down on November 10th. Okay. Here's the next one. When will it be enough vaccine to inoculate 25 million people? Now they say between October and March. 25 million people, that's a good number of people. Again, this on April 24th, as you can see, there were 4 different predictions. One was kind of low, and that's the one that is now the dominant one, right? What else do they have? You can look how they predicted the results of the presidential election that we had a month ago. The fiscal stimulus, what will happen with regards to the Tokyo Olympics that are now rescheduled for July 2021. And 96% of the people say that they will begin, of the forecasters, right? Okay. There's other things that you might be interested in. What would be, as of March 31st, 2021, the highest 7-day median of COVID confirmed of new cases in the United States? 69% of people, it's going to be more than 250,000 people on that day. Okay, what about, Europe? And so on. So if you are very anxious about the future, if these ideas of what's going to go with COVID keep you awake at night, look at the site and see how things changed. Again, these are super forecasts, and you can read about what makes them super forecasters. And here is an estimate of deaths. So what will happen at the end of March of 2021? They say it's going to be 500,000 Americans between that. Anyway, so something interesting to perhaps consider, giving us some hope in our life in the future. Okay, so see. So the site is Good Judgment, right? So it's goodjudgment.com. Good Judgment Project. Goody. So let's just finish a few minutes about now. After this whole almost 2 hours of talking, you perhaps know the answer to this question. So do you think we are rational as a species in general? Let's do our little poll. If you think we're rational, click yes. If you don't think we're rational, then we're irrational. Click no. Okay. Yes. Like I said, depends. Ha ha ha. No, Karen, I'm sorry. We are completely irrational. And we should always have that in mind. Hopefully, that would be one of the take home messages from this class, that we can spend all the time we have in stats or taking philosophy and logic and still do all these kinds of errors in our everyday life, especially when we are, but remember, this is under the conditions of uncertainty. If we have a Tower of Hanoi, no problem. We can figure this out. But good. All of you now know, those who voted say no. All right. So let's just talk a little bit about that, and then we'll be done for today. So, like I said, in the 19th, 18th century, even, the idea was that people will use principles of logic and probability and maybe some mathematics to deal with problems. But also, they may be swayed by self-interest, or they may try to calculate optimality in their decisions. There is even a special theory called the utility theory, which we won't have time to get to, but you again, we obviously rational. Depends, right? So it was the theory of rational choice, the idea that humans are rational and they will always follow rationality. Again, these are some of the people that have proposed this idea, including some of the philosophers from the 18th century and some of relatively modern behavior scientists, we would call them today, but this is 1947. So the idea was that we apply these principles to the economics, giving us the idea of homo economicus, like other Latin terms for our life before we think about all the classes we can take. But here is a good example, and I think we'll finish with that example. The one on the left, the Titanic, I'm sure many of you are familiar with. The one on the right is Lusitania, 1915, a different story. So let's quickly think about, rational behavior using this example. So let's think about Titanic. As you know, there were about 2,200 passengers on Titanic. They were obviously separated in different classes, first class passengers versus, second, third, fourth. If you have watched a famous movie with Leonardo DiCaprio, right? You know about it. So what happened with Titanic, we know quite well because we actually have access to what's left of Titanic. The stuff is quickly deteriorating, so the day will come very soon, there will be nothing left. But we do know that once the ship broke basically in two parts, as this is what you can see on this little photo, it took the ship, it was sort of breaking in two for a while. So actually it took almost 3 hours, or slightly more than 3 hours, for the ship to sink. Now, that means that the crew had 3 hours to do something, to do the duty, which was to save passengers. And what happened, we know now, more or less, in good details, that about 1,500 passengers died after the Titanic sank. Now, 3 years, this was, I think, was like April, perhaps, and there was an iceberg, in case you don't remember. In 1915, this is the First World War. Germany and the UK obviously were in the state of war. So there was this other, probably another most famous tragedy with this ship called Lusitania, which was a passenger ship. In this case, it was actually, so Titanic was going from Liverpool to New York. Lusitania was coming from New York to, where did they go? Maybe Manchester, somewhere in England. Okay. So it was torpedoed by a German submarine. So what happened, we know again the numbers, that almost 1,200 people died, because these were all civilians. This is not a warship. But the difference is, and I think you can see that on the slide, is that for Titanic to sink, it took 3 hours. For Lusitania, it took 20 minutes. So now I want you to think as a rational human. Yeah, rational, right? What if you were a passenger on either of these ships, regardless of your gender or age? What should you do? How should you act? Well, it's on the bottom of the ocean. Lifting it is just not possible. It's way too expensive. Try to stay calm and listen. Leave the ship, yes. Go to the lifeboats. And in doing this, right, you should not take any jump. No. The Titanic is April. Lusitania is May. It's you basically, the shock of incredibly cold water will, if you watch the Titanic and you know the two of them, she's floating for a while, technically it's very, very difficult to achieve. The shock of the extremely cold water shuts down all the biological systems of the human body, but ignore that for a second. So you guys, limited lifeboats, but you are acting as a rational human being. As a rational human being, your goal is to save yourself, right? Now, if that is the case, right, then who should have been, well, okay, let's take, yes, let's take gender and age. Let's take gender first. Going by the rationality of human species, who should have had higher chances of survival? Men or women? I'm talking about rationality now. No, Denise, rational human being is survival, right? That's right. So men should be having more chances. Okay, adults versus children. Who should be, again, having more chances of survival if you are rationally behaving? Adults, absolutely, yes. Now, see now what happened. Interestingly, I have the numbers here. So I'll tell you. Okay, and then you guys, in the last minute, will try to explain that. So I'm reading you the numbers. So children on Titanic, 14.8 higher chance of surviving versus Lusitania, which was 5.3 less chances of to survive. Women had 50% higher probability of surviving on Titanic compared to men, while Lusitania, they had 1.1% lower chances. So why is it that women and children had better chances of surviving on Titanic than on Lusitania? Yes, time, Brandon, right? But time, now I want you to cross the time with rationality. What happens when we stop thinking rational and we start thinking as humans, right? As human beings. All right. We start thinking about cultural norms, and the cultural norms are such that, yes. And why would they put women and children on lifeboats? If the rational decision would be to save yourself, because now the cultural respect, exactly. Respect is a cultural norm. We try to save those who are weaker, right? So children and women. But you can only do it if you have time. If you have 3 hours to think about it, you can push yourself into the mode, okay, men and women and children need to be on lifeboats. When you have only 20 minutes, all the cultural norms go out of the window. And that's what happened. Okay, guys, I'll hopefully see you for our last class on Tuesday. Class is over. Thank you for stopping by. Take care, Amanda.
Bye, Professor. Have a blessed day.
Great day,
You too.
Professor.
Take care, Leroy. Bye, Julia. Bye, Karen.
Bye.
Oh, Karen, you want to talk to me?
Have a good day, Professor.
Okay. All right. Take care. That's okay,
So
Karen.
is Tuesday mandatory?
No.
All right.
If you don't want to ever see me again, that's fine.
Professor, I sent you we spoke about the t-tests.
Did you use what I sent you?
Yeah, so I emailed you that back.
Good. That's the correct t-test, Isaac. Because you didn't tell me how you conducted your t-test, I could not help you, so I just sent you what it should be.
Thanks.
As long as you used it, you should be okay.
Yeah, so we submitted one as like a placeholder, but I emailed you at like 11.
Okay, good.
Thanks.
All right, take care, everybody.
Take care, Professor.